So there's a question, interfragmentation question. There is a process of 72,766 bytes. Capacity of the frame block is 2048 bytes. How many frames will be required process to load it? So to load this one, how many frames we need, and find out the capacity of the internal fragmentation. So when we take the entire capacity and divide by 2048, we will get 35 frames, and remaining portion we have the 1086. So since there are 1086 to be saved, so we have to find the 36 frames. We need 36 frames. So 1 2 3 like that, up to 36 we have to take. So when we are going to use 36 frames or block, both are same, frames, blocks, pages, both keywords we are using as same at this moment. But later on, we will discuss the differences between block, frames, and the pages. So just keep in mind, blocks mean the blocks equal to frame equal to pages. Okay, so block normally comes with the program, and when it is saving in the frame, we call as, when it is saving in the random access memory, we call it as frame. When that block is saving in the uh, hard disk, in virtual memory, we call it as pages. Okay, so page size, frame size, and the block size, both all three are same. So same programs, block unit of program section, we are going to save in two locations. So in a program, there's a small unit of uh, program block, so that is going to save in the hard disk, we call as pages. When it's saved in the frames, we call it as random access, we call it as frames. Okay, so now when we use 37 frames, that in the last 30, when we use 36 frames, the 36th one need only 1086, 36 frame. So there will be free space for the uh, in that 36th one. So the free space is 2048 minus 1086. We will get 962 bytes of space. Okay, just check your answers. Next question, for file size is 10,400 bits, bits, bits. That mean we have to check about bytes. Okay, so calculate the wastage in the file space due to the incomplete filling of the last cluster. So we have 10,400 bits, then we have to divide it by 8 and find the bytes. So you will get the 1,300 bytes. So the file size is 1,300 bytes. Calculate the wastage in the file space due to incomplete filling of the last cluster. Assume that the cluster has the size of 512 bytes. So find out the internal fragmentation. First, if you get this kind of question, check about the bits and bytes. So take everything into one format. Normally we take it to the bytes. We are not going to simplify with the bits. Most of the time we take it to the bytes. So 512 bytes also then. So then 1,300 bytes. Then we divide it by 512 and find the number of clusters, is number of block sizes. So cluster, we did it, assume that cluster has, that means sector. Just think, can call a cluster is a small section, where smallest unit of section where we save the file in the hard disk. hard එකේ පුංචිම කොටසක data store කරන පුංචි size එකක් තමයි cluster කියලා කියන්නේ. sectors කීපයක එකතුවක් වගේ cluster වෙන්න පුළුවන්. ඒතර block size එක වෙන්න පුළුවන් clusters ක්ලස්ට් එකක් සමානයි බ්ලොක් සයිස් වෙනත් පුළුවන් සමහර ලාවට. ඒ කියන්නේ සෙක්ටර්ස් කීපයක් එකතු වෙලා 8 KB නම් තියෙන බ්ලොක් එකක් නෙමෙයි මේ සෙක්ටර් එකක්. ඒතර අපිට 10 KB වගේ ඕන නම් ක්ලස්ට් මේ ඕන නම් ඒව එකක් හදාගන්න. නැත්නම් ක්ලස්ටර්ස් එකට බ්ලොක්ස් දෙකක් එකතු වෙලා තියෙනවා. 8 KB 8 KB දෙකක්. Hi. Find out the internal fragmentation. So file size in byte is 30,300. The required number of clusters mean blocks. Just think it's a block. We need two blocks and remaining 276 to be saved we take another one more, that means 3. So three clusters, 3 blocks are needed, but remaining portion wastage is 512 minus 276. We will get 236 byte as the internal fragmentation. Okay, shall we do it? Next one, 2012 structured Part B model paper. So calculate the wastage in file space, internal fragmentation due to incomplete filling of the last cluster for the file size 25,200 bits. Assume that the cluster size is 512 bytes. So since that also consists of bytes, we have to come to the one particular format. That means I will take it into the bytes. So 25,200 bits divided by 8, I got 3,150 bytes. So altogether 3,150 bytes. So size of a cluster means another block size. Okay, just think cluster is the smallest unit where we save the data, smallest unit. So all the sizes are equal. Okay, so block sizes are equal. Just think like that. So block size, if the cluster is hard, think that is a block or the sector. පුංචිම කොටස data save කරන hard එකේ පුංචිම data save කරන unit එකක් කියලා හිතන්න cluster කියන්නේ. ගොඩක් හිතන්න යන්න එපා. 512 නම් එකකට. ඒ කියන්නේ එක van එක දාන්න පුළුවන් ළමයි ගාන 8යි කියලා ඉස්සලාගේ 10යි කියලා වගේ හිතන්න. ඒ වගේ 10 සමානයි 512. 10 වගේ van කීයක් ඕනද කියනවා වගේ ළමයි 10ක් නම් යන්න පුළුවන් එක van එක van කීයක් ඕනද කියනවා වගේ එකක් 512ක් නම් දාන්න clusters එක තියෙන්න පුළුවන්. එහෙමනම් 3,150 ඇතුලේ කොච්චරක් තියෙනවද කියලා බලන්න. So we divide 3,150 by the number of the size of the cluster, then we can find the required number of clusters. So we need 6 clusters and 76 remaining. So 76 remaining mean we need 7 clusters. So when we use 7 clusters, there will be extra space at unused free space. So 512 minus 78, we will get 4,304 bytes. So that is the internal fragmentation occurring this one. Okay. So shall I write the question and try this one? Then next week we will do the external fragmentation. Okay. Next week we'll see whether we can arrange or not. Just copy the question.